ionization energy, or in the short form of IE, is the minimum energy required to remove 1 mole of electron from 1 mole of gaseous atom in its ground state. Well, generally, IE will increase across the period. So we should observe this kind of trend, right? But this blue trend is not the right one. Okay, because we've got the anomalous case of beryllium and boron, nitrogen and oxygen, and the second anomalous case would be between the magnesium and aluminium, together with phosphorus and sulfur. But in this video, I'll just explain the first case. For beryllium and boron, in order to understand the anomalous case further, we need to write down the electron configuration first. So I already write down the proton number for each element. So beryllium would has 1s2, 2s2. And boron would have the electron configuration of 1s2, 2s2, and 2p1. So remember the IE is about removing electron, removing 1 mole of electron. So we're gonna form an ion with a positive charge. So in short, we're gonna form cation. So which element between beryllium and boron would be difficult to removing its electron? So that would be the case for beryllium. So we notice that for beryllium, the valence shell consists of 2s2, but for the boron, it would be 2p1. Remember back in chapter 2, okay, so this is s orbital, so we're gonna say that this one is fully filled, whereas the 2p only be halfly filled with 1 electron. Hence, it would be difficult to remove 1 electron in fully filled and stable 2s orbital of beryllium. Removing 1 electron from boron orbital, from 2p orbital in boron is easier. So the IE for beryllium would be higher than that of boron. Okay? Because beryllium is fully filled, so we need extra energy to remove this electron. Okay? Compared to boron, which only has 1 electron in 2p1, so it would be much more easier to remove electron in boron. So it has lower ionization energy. For nitrogen and oxygen, nitrogen has 7 proton numbers, so it would be 1s2, 2s2, 2p3. For oxygen, that would be 1s2, 2s2, 2p4. Now, you have to draw the valence orbital diagram. Okay. So 2s2, 2s2 is just the same for both nitrogen and oxygen, right? So we're gonna draw the 2p3 for nitrogen. Remember class, for the Hans rule, fill in electrons singly first. But for the oxygen, we've got 2p4, so 1, 2, 3, 4. So now tell me, what kind of stability is this? So the 2p3 in nitrogen has the half-fill stability. But what about the stability in oxygen? No, it doesn't have any stability. Remember that we've only got 2 kinds of stability, which are the fully filled and the half filled. And these 2 are stronger than any partially filled orbital diagram. So it would be difficult to remove. Remember that we are talking about IE, so we need to remove electron in half-filled and stable 2p orbital of nitrogen. For the oxygen, we can say that the repulsion between two electrons that occupy the 2p orbital in oxygen is higher. Okay, so these two electrons in red, so they are the same charge. As I mentioned earlier, that they're gonna repel each other. So this electron will be easier to be donated. So the IE for nitrogen would be higher than oxygen.
The stability causes the ionization energy to not have this graph. Okay, so if we follow this kind of graph where the boron would has a lower IE than beryllium, and the oxygen too has a lower IE than the nitrogen.
The definition for electronegativity is the tendency of an atom to attract electrons toward itself when chemically bonded. So let's say I have the molecular formula of HF. So hydrogen, we know that it only consists of one electron, while the fluorine, it has 7 valence electrons, 3, 4, 5, 6. So what's going to happen? Fluorine, it is more electronegative than hydrogen. So the electron for hydrogen will be attracted toward the fluorine. You can say the electron is attracted to fluorine. And the relationship between the electronegativity and IE is directly proportional. So when IE increase, the electronegativity will increase as well. Okay. So you must refer to first page of your tutorial for chapter 3, okay, because I already explained it beforehand. And one more thing, class, can you write down a quick note? So this is very important for the starting for chapter 3. You have to know that FON, the fluorine, oxygen, and nitrogen, so these three are the most electronegative elements in the periodic table, but fluorine is the most electronegative element. Okay, so going from N to F, the electronegativity will increase, whereas fluorine is the most electronegative element.